Amounts of reactants and products. From a balanced chemical equation, we would like to calculate the theoretical amount of product that can be formed, or how much of a reactant will be consumed. We have to convert the quantities of known substances into moles. We use coefficients in the balanced equation to calculate the number of moles of the quantity sought. Finally, we convert the moles of the quantity into grams. Let's take a look at an example. Methanol burns in air according to the equation 2-methanol plus 3 oxygen yields 2 carbon dioxide plus 4 water. If 209 grams of methanol are used up in the combustion, what mass of water is produced? We're going to take the grams of methanol, convert it to moles, convert the moles of methanol to moles of water, and finally the moles of water to grams of water. 209 grams of methanol divided by 32.0 grams, the molar mass of methanol, times 4 moles of water for every 2 moles of methanol, times 18 grams of water per mole of water, yields 239 grams of water. Notice that 4:2 ratio there. That's called the mole ratio. If you look at the balanced equation, there are 4 moles of water for every 2 moles of methanol. Theoretical yield is the maximum amount of product that would result from a reaction. The actual yield is the amount of product actually obtained by experiment from the reaction. The percent yield is the actual yield divided by the theoretical yield times 100. If only 119 grams of water were produced in that previous example, where the theoretical yield was 235 grams, what would be the percentage yield? Simply 119 grams divided by 235, the actual over the theoretical, times 100. The percent yield is 50.6%. Limiting reagent. Reactant first used up in a chemical reaction is the limiting reagent. Take a look at this reaction. 2 nitric oxide NO reacts with 1 mole of oxygen to yield 2 moles of nitrogen dioxide. If you look at the graphic, you see that the oxygens are the diatomic, the 2 red spheres, and the nitric oxide are the blue and red spheres. The reaction proceeds. The NO turns out to be the limiting reagent because the oxygen is in excess. There's oxygen left over when the reaction is complete. We're going to determine limiting reagents in problems that we'll do in class. The method is to calculate the yield for each reagent, and the reactant that gives the smallest yield is the limiting reagent.